we will walk through this learner notebook and have a look at how the FastAI training loop utilizes callbacks and why are they needed at the first place. So in this notebook, first some utility functions are defined. So here you can see some simple synthetic data loaders and model. All this stuff is used for testing, and also some other utility functions defined here, but that's not particularly relevant to what we're gonna consider today. So yeah, the first thing we should notice here are defined some variables, and these are used for callbacks actually. So this before epoch and after epoch, you see it's just like a variable to combine before fit and before epoch, and yeah, they happen in like this order, and after epoch we do call after epoch and then after fit. So just I think that those are just also for some tests here, and here we can look at this variable called event, which holds all the possible events, and Srinivas mentioned this previous session. So there are total 22 events available in FastAI training loop, as you can see, and yeah, here we can just check all those events. Basically, they follow their order, which is which describes a general training loop for neural network. And yes, here for some motivation, why FastAI training loop is done the way it's done, I think it's useful to consider like what is the basic training loop is. And here is some like pseudocode for one epoch of training. And we iterate through data loader, right? And compute predictions, feed in inputs to the model, then we compute loss and compute gradients using this loss. Then we do one step for each batch, and we need to zero gradients after each step. And suppose we want to modify this very simple training loop to include something extra. So say we want to add gradient accumulation. And in this case, we will have to rewrite this training loop here, because it's like not possible to modify such kind of hard-coded training loop any other way. And we might add some parameter here, like say become steps equals to something, and then we will have to divide loss by we should probably set it to 1 by the default, and then divide this loss by number of steps. Then we will have to like set here a condition that if, yeah, we will have to like enumerate all batches. And yeah, so probably I shouldn't continue. You see that even such a simple modification as adding like gradient accumulation requires some like code in here, rewriting some code, and we can do some mistakes and while doing that, and also definitely you will have to have a lot of this function definitions if you want to, if you need different training loops for different models. So, and this motivated this FastAI training loop, which seems somewhat like strange, maybe at the first glance, but then when you get familiar with it and start using it, it really like the flexibility shines. So let's have a look at the definition of the learner and how callbacks are used here. So as you can see here at definition, we can pass a list of callbacks to the learner, and those would be stored in this list called CBS and available through that attribute. And you can see here that there are some methods to add callback, remove callback, and add bunch of callbacks together and remove multiple callbacks. And yeah, so what happens when we add callback to learner? Yeah, so the first here, there is a check if we pass a class instead of instance, we make it an instance. Then the callback learn attribute is set to self, which links this learner object to a callback. And then we can set attributes on learner accessing in callback, like by setting, by doing something like, say we want to modify input batch inside of callback, then we will do like self.learn dot x batch equals some like modified x batch. Yeah, so and then we we define this attribute which would be callback name on learner, and in this way each callback can be accessed through learn dot callback name. For example, if we have a recorder callback, it will be available through learn.recorder here. And then we append to this CBS list. And,
sorry, I have a quick question. So I understand the setting, the attribute, the little bit still when or trying to understand what the cb.learn is self. So you're saying that line helps us make the learners the callbacks learn attribute?
So yeah, this line, right?
Yes.
So each callback will have this learn attribute, and it will be able, like we will be able to access all the learner attributes. Like we will be able to write to all the learner attributes by doing like self inside a callback. So this yeah, so this is when we are inside the callback. So in this case, self would be a callback self, right? And it will have this learn attribute. And we can, for example, set the like input batch to like modify it somehow and set it to the learner. So in this way, we can modify learner attributes inside a callback. So when you're inside the callback, all the learner attributes, like if you remember that, like attribute delegation. So the will be like when you inside the callback, the attribute lookup will be redirected to learn if these attributes are not in callback. But you cannot write in the same way. Like, so what I'm saying, like you will be able to do self.xb to access this x batch inside a callback, but you will not be able to set here anything because it will result in error because yeah, because you like cannot write to this. It's done to avoid some mistake when you basically, yeah, maybe it will not result in error, but it will not modify the learner attribute. Learner attribute. Yeah, so it's done like to make it possible to use some attributes inside of the learner inside of callback like separately, but also you can assign to learner attributes like which will be linked to the learner itself, not to the callback. I don't know if I explained it well.
Yeah, I think I got it better. Thanks.
Yeah, maybe we will look at some example when it's used, and it's really nothing special, but you just need to know that you can read the learner attributes like this. But if you want to write to the learner attributes, you need to set it to learn.attribute, self-learner attribute. Okay. And so here is how we remove callbacks. Again, it's we just run through the list of callbacks, grab all the callbacks which are of this class of callbacks we want to remove, and then we just unlink the learner from the callback and remove all the traces of the callback here. You can see how it's done.
Sorry, one more question, and it was there a few screens back. So the default callbacks are those 3 callbacks we discussed last session?
Yeah.
Like the recorder and there was some progress bar and...
yeah, so here in this notebook, as I saw, the default callbacks are only train eval callback.
Ah, okay. So there's that one.
Yeah, yeah. Actually, no. Here you can see this. Let's print it. Basically, yeah, there are. Default.
It is recorder and train eval. Okay. Train eval callback and the recorder callback.
Yeah. Default callbacks. Yep.
Okay.
Yeah, so recorder and train eval callback. Right, so where we was, and yeah, so there are some, also you can, it has this context manager, so you can do something with edit callback. It like you can specify a callback here. It will be added like when you enter the context manager and removed after you like at exit. And the same can be done like you can remove some callback and then add it back when you're done. It might be useful, for example, when you have some callbacks which are specific to training and you want to remove them at evaluation, I guess, or you may want to remove some like progress bar callback when you want to run something which will not be displayed, or yeah, so there are some use cases for this, and probably we will see them as we progress here. Yeah, so now there is this ordered callbacks. It will just, you see it has this event argument, and it returns all the callbacks sorted by order. And if this callback has this event method corresponding to the event of interest. So yeah, so this is like utility method which will return all the callbacks for the event in order. And here you can see that when you like call the learner object, it does the following. It calls here this, you see it like maps a call one method on the event, and here is call one. It will simply call all the callbacks for the given event. So that's how callbacks are called. Okay. So does it make sense, right? And now,
sorry, please. I can't really remember how this works. So, like the event names, how are they gotten? Are they gotten from like the name of the name of the event itself? Like, maybe.
Yeah, we will get to how when the events are called just next here. This with events method. And it handles the calling of proper events. So yeah, so if you understand how all this works, you will understand the FastAI training loop. So this what this with events method does. It has some function. We have here some function and event type and exception we want to catch when doing this with events. So here what we do, we call before the event. For example, say we want to do this with events feed. So it will first call before feed. Then it will execute some function passed to it. So it will do something useful. here probably. And then we have here this except statement, and this we will here we will pass, for example, event type will be fit, and the exception we pass here will be cancel fit exception. And yeah, so in this case, if the exception is raised during the event, it will call after cancel fit here, and in the end in this case, yeah, so after fit is after cancel fit is called, then we call after fit, and then we call final, right? And final is also something we can pass here, and by default it's nothing. We do nothing in this final event. And now we can see example of use of this with events. How it's used to do one batch. So here is here you can see this do one batch method is defined, and it does basically a training step for a single batch. You see here predictions are calculated, then after pred event is triggered, then we have this. So if we have multiple outputs, we will compute loss function for this multiple outputs, and yeah, so then we call trigger after loss event. And then if you see here, if not training, we will return. If training, we will proceed to, we will do before backward, and then call the backward method on loss. And then this we use this with event we considered earlier to do a single optimizer step. So here you can see the first usage of with events, and here the function we call will be optimizer step. And what this with events will do, it will first do before step and call all the callbacks we have. For all the callbacks we have, it will call their before step method. Then it will do the step. If cancel step exception is raised, it will do the like cancel step, like after cancel step event, and that it will do after step and exit. So that's how the step is done. And yeah, so in the end we zero the gradients. So basically you can see that's the same basic training loop we discussed before, but like at first it seems like it's somewhat more complicated than it should be, but this allows a lot of flexibility. So basically each of this event allows you to do whatever you want. So for example, if your model returns not only predictions, but say something like for transformers, sometimes we have we might have here predictions and attention metrics. But you know, but your loss function only expects to have predictions, and maybe you want to do something else with attention metrics. I don't know, to store it, for example. And you can define a callback which will have this after pred event method defined, and we will like in this after pred event we will set like learn that pred will be equal this self pred 0, because we have two elements here and we want only the first element to as actual prediction, and we can do it with this this attention matrix, whatever we want. So it's also, we can get it at this moment of time. And yeah, so this one possible like use of this event. And basically for each of this possible moments in training loop, when you want to do something something special to what you have inside your learner, you have this entry point, which is an event, and you can like modify all the attributes of your learner at each of that points.
Question, Arto.
Sure.
So what is what are event type versus event name? Or how to remember the difference and what is each of?
Yeah, basically, I think that event type and event name is kind of the same. Okay, the event type here is like, say, feed, for example. We have two, like for a single feed call, we have before feed, after cancel feed, and after feed, you know, and all this can be like generalized under a single event type, which is feed, or say we have a type of event step, and for step we have before step, after cancel step, and after step events. So event type is like this concept of something happening. Here you see step, batch, train. Basically that's like we can say number of events like united by a single logical sequence of events, right?
And event names, on the other hand, are those kind of like
yeah. So event name is this specific event which for which we have which is in that event list we saw before.
Yeah,
and
the 22 ones then.
Yeah, and okay. Each of it is triggered at some point during the training loop.
Got it.
Okay, so basically this event type is a way to make sure that when we do with something with events, that all relevant events are triggered for this event type, right? Okay, and so here we defined do one batch, and now there is it's like a helper function, and here is one batch method which basically does a single batch. It's called with some index and the batch. And here you see that what it has in addition to this do one batch, it sets like iteration to the iteration passed to the call, and it makes sure that the batch is on the device, so on the data loader's device. Then this split method divides a batch. So here the batch it contains both inputs and targets, and split method divides it into separate like x. It writes an attribute xb and yb to the learner. And if you may have like multiple inputs, and you specify it when you construct your learner, and it's used when you split properly inputs and targets here. And in the end, we just call this with events again. This time, the function we want to execute with events is do one batch, and the event is batch, right? And it has a relevant exception. And in the same manner, you can see that epoch is done. So we execute this all batches function during training and validation. And you see, we just select a data loader. For training, it would be training data loader, and for validation, we have we can call validation on like validation set, or maybe we can change this number and call it on test set if we add it, or we can pass like a test data loader here. But it is basically very similar. So we do a single epoch with this data loader, and it's done with all these events. So for example, when we do with events train, it will do before train, and for example, train eval callback will have before train method, which will be called, and it will like set model to training mode, and when we do evaluation, it will have before validate method, and it will set model to eval mode, and also set this training argument on learner. And you see that epoch is just a sequence of these two calls, and a fit is done in the same way. So we iterate over epochs and call with like with events epoch. We do basically what was it maybe like read. We do epoch with events, right? So it sounds like self-explanatory. And here you can we finally got to this fit method we can use on learner, and you can see here we pass number of epochs, learning rate if we want to set specific learning rate, weight decay. we can add some callbacks here and potentially reset optimizer state. And here it's handled. So if we decided to reset optimizer, the new optimizer will be created. And if we provided any of learning rate or weight decay, we will use those provided. If not, we will take the default hyperparameters here from when we define learner, and it has some default values for each of these parameters. And yeah, and then again we just do this. We do fit with events, so it will be. It will call before fit and after cancel fit and after fit. And here you see we have some end cleanup. In previous cases, this final was not used, but here it's used to remove all the stuff we don't need. So here it removes this list of arguments. It's like a data loader we were using. So it's not data loaders, but like which we pass at creation, but it's like a data loader which was used at a particular time when fitting. And also it, you see, it sets to none this like X batch, which is input batch and target batch, and also sets to none like pred and loss attributes of learner. And yeah, so that will release some memory and make sure that when we finished fit, we will have all nonce. And yeah, if we run fit the next time, it will all be like we will have a fresh start for this attribute. So yeah, and that's basically a FastAI training loop, and yeah, it has a lot more here, but that's not what we want to focus on right now. And we can move further to the where he shows something of the, how it works. So here is training loop section in the notebook. And here you see he sets the default callbacks to train eval callback if defaults are not defined. So, and then we create some synthetic learner. It will be a simple regression model. And now we can take a look at some tests which are done here. So here we have some synthetic learner. And we do this before epoch. And if you remember, this was defined here, and it does before fit and before epoch. So we do this before fit and before epoch calls on learner, and then we like basically we do some a part of training loop here manually. So we send a model to CPU, we get a single batch of data, then we compute a loss on predictions. Then we call this fit, and he checks if their loss improves. Then again, we manually grab one batch, compute loss, and check if actually learning has improved the loss. So that's what's going on here. And here you can see this. Testing can be done also using callbacks. So we can create a callbacks which will, after each event, they will do something we want to, like to run the test we want to perform. And here you can see that this test train one callback has run after attribute, and it should be run after train eval callback. Yeah, so here you can see what are the tests, and first it checks that before we start fitting, we have like 0% training done, and it's 0 training iteration. Then we check if their model parameters are on the same device as data here. So because train eval callback should send a model to the data loader's device. So this is tested here, and then here it's tested if the training iteration and like this training statistics is incremented properly, and if the learner is in training mode. And also you see here some other tests. So for example, before train, we test if the training percentage is equal to the current epoch divided by total number of epochs, right? And that model is in training mode. And before validation, we test that both learner and model are not in training mode. And yeah, so that's basically shows what this train eval, everything that this train eval callback does. So it's responsible for like some. And here we can have a look at the source code of train eval callback. And you can see that it, so that what is that? It has slow order of -10. So most of the time we want to make sure that it is called first before any other callbacks are called. And yeah, so here you can see that it handles like proper counting of the number of training epochs, steps, and all that stuff. And also it sends model to the data loader's device. And here, this reset, it's useful for RNN models. So every time when we start a new feed, we want to reset this RNN models, and that's why it's done. So, and you can see here that again, this training iteration accounting is done, and also this training attribute is set, and the model is like we call here train and eval on model when needed. So next we can check this one batch and what it does. And here you can see that when you call one batch, he checks that this X and Y attributes are properly set on learner, and that is done by that split method we saw before. And basically here again some tests, and we can look at this verbose callback, which just is a simple like addition to the callback class, which is like the basic callback class for subclassing, and here it's modified to do the same as callback, but also print the event name every time it's triggered. And it's also useful for testing. So yeah, here you can again. So probably I would need to like run all the cells here. So which I didn't do, and that's why here is some error. But let's see if we can probably need to that will cause some errors too. Yeah, but generally, if you'd like, we can have a look at some examples of callbacks and how they are used. For example, I can show how callbacks can be used to train the model for translation. When you do translation, you have this like input and target sentences, and basically you want to feed to the input sentence to the encoder and that target sentence to the decoder, and then you want to construct your like actual target from this target sentence, target language sentence, and so I can show you some examples of how this callbacks might be. How would you define some callbacks to adopt this training loop to the translation task? So here, for example, as I said, for when we do translation, we have this target sentence and source sentence. And source sentence in this case was in X, and the target sentence was in Y. But actually, the model expects to, when it's trained, we want to feed both this source language sentence and target language sentence to the model when we do prediction. And that's how we can grab this X batch and Y batch from the learner, and set this X batch here to be a tuple of both what was previously X batch and Y batch. And here another thing which is done. Basically, when we do translation, we have this input and output, and it is done in autoregressive manner, which means that for each word, the next word is its target, right? And we want to construct from this source language sentence both input and output for the decoder, and we want to remove EOS token, which is added at the end of each sentence, from the target. We don't want to predict this EOS, but we want to have this EOS in their input to the decoder, but we don't want to have it in the targets because we don't really try to predict it. And this is how we can construct a callback which has this before batch method. So it will be each time the batch is grabbed from the data loader, we will create this mask for end of sentence tokens and end of stream tokens, and we will remove those from X we have here. Yeah, so it's removed from not from target, but from this input to the decoder. Yeah, yeah, and we can you can see that here we can create a simple callback if we want. For this. When we train with this autoregressive objective, and for each token, the next token will be the target for each, and we can create this by simply we can create this shifted target by simply indexing to the original target. And here is another example of how callbacks can make life simpler. So here we had some model which required each batch was required to be of length multiple to some number here, and here each batch is dynamically padded to the multiple of that number for that model to work. So we do not modify our data loaders to padding, but we can do this in callback, and yeah, that's just simple. Yeah, so that's one example of how FastAI callbacks might be used. And also I can show you another example.
Sorry, Arthur.
Yeah,
I noticed
sure.
you didn't set order, or I don't know if I missed it on any of your callbacks. So how do you know?
Yeah, so these callbacks will have the default order, and
Yeah.
it's not particularly important when are they called. They are just called in this case. Those will be called in the order they are added.
Okay,
And
okay.
and the default order will be used to order them with respect to other callbacks we have.
Oh, cool. Okay, I just wanted to confirm. Thanks.
Yeah, sure. And here I had some, let me find it. So we here is a tool to show the memory used by a model when training, and this memory recording is done using callbacks for FastAI. And for example, so what we have here, we have this memstats callback, and it can be used to profile memory usage. For example, here you can see the difference of how much memory is allocated for when you use different optimizers. For example, regular SGD optimizer, it has the lowest memory usage because it does not collect any statistics. But for Adam, we keep a lot of averages, of parameters, and Adam has a lot more memory needed, and there is this other factor optimizer which is said to be to perform similarly to Adam, but it has much less memory usage. So basically, how can you use the callbacks to record memory statistics during training? And here in FastAI, there is a hook callback class, which is basic callback when you want to use PyTorch hooks. And here, for example, we can define this memory callback and record we will register hooks for all the modules in the model, and and it has this and after we're done, it will remove all the hooks, and in this way we can easily add this PyTorch hooks and use them during the feed call. And what those hooks do, they just record the memory statistics, how much memory is allocated, and let me find where those defined. So here you can see that the hooks are created, which just record some information about how much memory did we use and what were the input and the output for this for a particular model and stuff like that. And basically you can see that it's like quite short and but allows you to record like detailed information about how much memory is used by your model, GPU memory is used by your model during training. Also, there is another example of callback. Just if we want to profile memory usage for a single like for a single batch, we can define a callback which will just break the fit like call during the training. And here you just defined like a couple of methods which will raise the exceptions. And in this way, for example, we can avoid during doing optimizer step when we do this memory profile, and because we don't want to update model parameters each time we just want to like to record the memory statistics, but don't want to affect the model. And this can be done by using the exceptions. So yeah, so that's what I had about this callbacks. And if you'd like, we can like have a look at some stuff again, or you can ask questions here, or we can have a look, like a more detailed look at something.
Thanks, Arto. That was great, I think.
Yeah, quite like that memory profiler you built. It's really neat.
Yeah, one request, Arto, if you could provide the links to the GitHub page that you were pointing to on Slack, that'd be great, because I think definitely could use examples that.
Yeah, this, okay, yeah, sure. I will.
That one and the translate one, that I think the reformer one too, that was.
Yeah. So those are, the reformer was this project we made. I told about it.
Yeah, the
for reproducibility challenge.
Yeah,
and this memory profiling tool is just a small thing I made for that project.
Oh, cool.
So I have a question. Did you create your own custom callbacks before?
Yeah, sure. So this this library I wrote it, and yeah, I like basically probably this is the most elaborated callbacks I done, but yeah, I use callbacks here and there when training with FastAI for some small things, as I showed, for example, for that translation task, and also that dynamic padding I mentioned, it was necessary for reformer, and things like that. It's basically like not very complicated. You just want to know when you want to do something with, for example, with some attributes of the learner, and how do you access those attributes. And the list of available attributes are in FastAI documentation here, and we saw those before. Like here, you can see that there is a list of all stuff you can access, and yeah, you can like modify it in whatever way you want. So that's
I quite
it.
like using like I have a question about this callbacks. I don't know if you
Yeah,
like
sure.
tinkered around it with the progress callback, because well, I don't use FastAI that actively, but I know with the progress callback back then when I used to use FastAI, it had issues like when you're running on the terminal, you know, when you just send a job to like maybe your cloud computer instance, it used to have rendering issues. It keeps rising HTML. So is there like a way to like completely remove that fast progress dependency and maybe add TKDM? Maybe by
Yeah, you
writing
can just do like here you can see that there is no bar. It's a context manager, and so it will be just removed from this stuff, and you just do this with no bar, with learn dot no bar, and it just removes the progress callback.
So what does it default to? Like, is it TKDM or what does it default to like with no bar? You won't see any.
I guess it's.
I'm asking because I had like issues with this. It's one of the reasons I even stopped using this, because it just kept like rendering HTML on the terminal.
Yeah, I will try to like show how it can be used. Just set here. Yeah, so one thing which is not very cool about FastAI right now is that it has there is no latest FastAI version on Collab, and you have to do like weird stuff to make it working. So the easiest way is just to install it with no dependencies, because it has like dependency for Torch to be to be 1.7, but on Collab you have 1.8, and you can do there is Light the Torch library which handles that, but I just install FastAI without dependencies if I want to run it on Collab right now. So, but that's not ideal, I would say. Yeah, and let's just get some basic data sets, data set, and here it will take some reasonable time, I guess, and we can do it. So the learner is ready, and that's pets data set. And we can start. Okay, let's first do it in a regular way. So here is this progress bar displayed, and then we can just do the same. should be no progress bar if everything works as expected. And probably we can just remove this recorder callback from the learner at all, and see if it will work. So here you can see that there is no progress bar, and hopefully the model is training, but we don't know because there are no progress bar.
Yeah, so I think I was trying to figure out a way to remove it. Sylvian built the fast progress library. According to him, he said that he hasn't been able to figure out a way to render it properly on the terminal. And then removing the recorder callback entirely, I don't really know if Jeremy has figured it, because I tried to do it, I couldn't figure it out, because there are a lot of there's a way fast progress is. The way it's not as straightforward as TKDM. Yeah, it's tied to the code very deeply. So I don't know if it's possible to just remove it like that.
Yeah,
I'll try.
Let's try it. So recorder callback, is it? See. Probably I mistype it or something. Let's check the list of callbacks here. Progress callback. Okay, yeah, progress. So it's called recorder and progress callback. So we want to remove the progress callback. So remove callback. Callback. Yep. And now we can see what if it helped. Yeah. You see, it's still
the same as Snowbar. Yeah, it's still. I mean, changing it to maybe TKDM or something like that. That is more friendly with the terminal. Adding a new tracker.
Probably there is a way, I think, to you want to have a printed progress bar, right? So for
yeah, something like TKDM. It's exactly like TKDM. Without all the
I see.
graphs.
Yeah, but you will get this just output of this kind. But yeah, that's not very helpful if you have if you're training on some bigger data. It will just print it every time the evaluation is done.
Yeah.
And, yeah, but probably for example, right now I was participating in this Hugging Face sprint for fine-tuning automatic speech recognition models, and used their Hugging Face trainer for training models. And it basically, it has this progress bar, but the outputs are printed and only at each evaluation step. But yeah, at least you have some estimate of how long the training would take, and here you don't have it, right? You need at least to wait for one epoch to finish to know how long does it takes. Yeah, but then you can just do take this number and multiply it by number of epochs, and you know it's training all right. But so you think this fast progress causes problems, right? With
it's not problems per se. It's when you use it outside a Jupyter notebook environment, it doesn't really. It just keeps writing HTML. It works perfect in Jupyter notebooks. Yeah.
Yeah,
it works perfect in Jupyter notebooks.
But I think I was using I was running FastAI training from in terminal, and it was fine. Maybe you should check it. Maybe they fixed what was causing problems to you, because yeah. So my last experience with it was fine, I guess.
Oh, okay. Maybe I'll try it. I haven't used FastAI in a while. I'll try it again.
Yeah, but what I like about FastAI is that it displays like all the relevant information in this progress bar. And for example, in Hugging Face, you cannot see like current loss, and that's not very like if you are used to see the loss dynamics. It is a bit like disturbing not to know what's going on there.
Yeah.
So
okay,
that's it. Any other questions or something?
Not. Go ahead.
Yeah, I was saying if you don't have any questions, so probably I will stop sharing screen.
Yeah, that's great. Thanks, Arto. And next week, if there's anything else besides what Arto has already covered, then I'll post and we'll go through it. I kind of wanted to look at what Zach Miller had shared and a couple of simple examples, and I'll see whether anything beyond what Arto has already shared or anything unique to point out. So keep a watch on Slack, and pretty soon I think that will probably bring us to the end of the set of discussions, unless somebody has anything else that they particularly want to cover from the FastAI library. And so I'm planning on reaching out to Joseph to see whether I'll post this polling to see whether people are interested in the self supervised and semi-supervised learning course from Berkeley as kind of a follow-on for this slot. So we continue to use this slot for something that we'd be interested. So keep an eye on that as well if you're interested. And if there is anything else in the FastAI library, particularly that we haven't already covered that you think would be important or relevant to spend 1 or 2 sessions, drop me a note as well.
Great. I had a quick question on, Arto, did you look at what about other libraries like Hugging Face compared to FastAI? Is that like more, is it worthwhile looking into those, or?
Well, for example, FastAI particularly is just like mostly about a training loop, which is flexible and customizable, and it has good coverage of vision models from my perspective, but I don't like have much to do with vision, honestly. And Hugging Face, so the main value of Hugging Face, I think, is that it provides a lot of pre-trained models for natural language processing. So they have basically FastAI and Hugging Face are focused on different things, and you can train Hugging Face models from Hugging Face using FastAI. Also Hugging Face has its trainer, and it like from my point of view, it has a bit less functionality. It's like simpler compared to FastAI training loop. But on the other hand, I think it works better with distributed training, and it has, for example, deep speech integration. And like probably FastAI will have one also, but it doesn't for now, as far as I know. So like all in all, I think that depends on your like use case. And there are some other libraries, like there is this PyTorch Lightning, which is kind of similar to FastAI, but I would say it's less beginner friendly, because there they have a bit different infrastructure to customize the training loop. There you will use subclassing, and so you got to write your at least part of training loop yourself every time. So that's like kind of a bit different, but it's closer to like regular PyTorch training loop, and might be more familiar to those who don't want to invest their time into figuring out how the FastAI works, but have some good knowledge of PyTorch. Yeah, so maybe someone else have some other opinions on that.
Yeah, I think it's also a lot of support for these transforms in the data loader thing that has significantly enhanced the PyTorch data loader concept to generalize it to language as well as to vision and tabular data as well, right? So it's, I think from that standpoint, FastAI is kind of built on top of PyTorch, but then flexible enough to go to at least 3-4 directions of NLP, vision, tabular, and I'm forgetting the last one, but so it's more general purpose as compared to, I would imagine, Hugging Face, which is oriented towards NLP problems, but with flexibility comes burden when you're not, the area is not your focus. So obviously Hugging Face would be superior for language related things, probably easier to use for transformers and stuff. Although I think FastAI also has capability for using transformers both in language as well as vision models.
Oh, and I just had a question. What is the third one that you mentioned that's PyTorch, built on top of PyTorch?
FastAI is built on top of PyTorch, right? It uses a lot of the PyTorch capabilities, but enhances it significantly, both on the data side, which is what we focused on, I would say probably on the entire FastAI library discussions, because that's what Jeremy focused on in the walkthroughs. But then the last few lectures, we are focused on the training loop, which he covered actually in one of the previous sessions. And the 3 application domains I was talking about are vision, NLP, and tabular data as well. He's built quite a bit of capability for handling tabular data and automated some of the steps along the way that PyTorch natively doesn't provide, but FastAI does.
Yeah, I think Arto mentioned another library as well.
Lightning.
Sorry?
Lightning.
Okay. No, because just from feedback in industry, like putting FastAI into production has a lot of, it's not as solidly supported for usage, but maybe it has to be customized extremely. I don't know. Yeah, so I'm just exploring all the libraries as well. Thank you.
Yeah, sure.
I think
About
FastAI.
Yeah. Okay. Go on.
Yeah, I think it's very good in production, like FastAI, but you have to like make sure you're on a particular version, because like lots of things are changing all the time. So you have to always stick to that version that you worked with. So I think that's like the major issue I have with it. Like because of lots of things are being added and removed a lot, it can break your code. But once you maintain that version that you worked on, I think everything should work really fine in production. Yeah. Yeah, you can go ahead, Ato. I don't know.
Yeah, from the production point of view, you basically can train the model using FastAI and then use other like PyTorch capabilities to deploy a model in production because like at the end, the model you obtain after training is a regular PyTorch model. So
yeah.
So FastAI is at least not worse than PyTorch, generally in production, I would say, because you can use everything you can do using PyTorch, you can do with model which is trained using FastAI. That's and also you have this data loaders with data loading pipeline, which might be useful.
Okay, thanks, Arto. That was great. And keep an eye out for next week. And if you have any specific items that you'd want us to spend a week or two at most on FastAI 2 that we haven't already covered, drop a note on Slack. If not, look out for what one of two possibilities that we may pursue next in this time slot. Thanks, everyone.
Thanks, everybody, for joining.
Yeah, thanks, Ato. Yeah, thank you, everybody.